The scientific revolution was a very important age in the history of Western civilization. This revolution had many great thinkers including Copernicus, Galileo, Newton, and Descartes. However, it is possible to determine who the greatest and most important person of this age was: Nicholas Copernicus. Copernicus was a Polish scientist born in 1473 who was originally trained in canon law, following in his uncle's footsteps. However, he decided that it wasn't for him and ended up revolutionizing astronomy. Previously, Ptolemy's vision of the universe with the Earth at its center had been accepted throughout the Western world. It both made sense and fit with the Bible's teachings. Copernicus challenged this idea in his book De Revolutionibus Orbium Coelestium Libri 6, or 6 books concerning the revolutions of the heavenly orbs. He explains that his hypothesis is that the planets do not orbit the Earth, but, in fact, the Earth, along with the other planets, orbit the Sun. This heliocentric theory was the first major step of the scientific revolution. Copernicus challenged what people had accepted as a fact, and this is a recurring theme throughout the era. His work was published in 1543, the year he died. He might have planned for the book to be published then so that the church couldn't persecute him for his teachings. Other astronomers read his book and agreed that a heliocentric solar system would make a lot of sense and explain things that Ptolemy was unable to explain. So, they made measurements and collected data of their own, namely Tycho Brahe, an astronomer who recorded the position of the stars each night. His data was key in the next step. Brahe's protege, Johann Kepler, was a brilliant mathematician as well as an excellent astronomer. He used Brahe's data and his own calculations to attempt to prove that the heliocentric theory was correct. He did this and something more. He discovered that the planets orbited not in a circle as Copernicus thought, but in a shape he called an oval, or ellipse. Galileo Galilei invented the telescope, or at least introduced it to Europe, and used it to look at Jupiter. Jupiter, he noticed, had moons of its own that circled it. As Jupiter flew through space, none of its moons fell away. He said that this was an example of how smaller objects orbited larger ones, such as how the Earth orbited the Sun, and that the Earth's moon would stay with it even though it was flying through space, as Copernicus's revolutionary theory stated. The Church disagreed with the heliocentric view because the Bible supported Ptolemy's theory of the Earth in the center. The Inquisition had Galileo tried and found guilty of heresy and forced him to recant. He agreed, but as he left the courtroom, it is said that he muttered, "Nevertheless, it does move." Copernicus' heliocentric theory started this astronomical revolution. He was the first of his time to challenge accepted facts and show that there was more to learn. His idea sparked the scientific revolution. Brahe, Kepler, and Galileo supported heliocentrism, built off of it, and improved the theory itself. This theme of people working together and building off each other's ideas recurs throughout the scientific revolution and the Enlightenment. Others use Copernicus' idea that something accepted by society for hundreds of years isn't necessarily true. Two men, one English, one French, created a system for proving things like this. Francis Bacon and René Descartes called it the scientific method. This required testing and proof of a hypothesis before it is accepted as a general fact. They examined medieval scholars' ideas and realized that they were all based off of assumptions made by Aristotle. Aristotle was a very smart man and a great philosopher, but that doesn't mean that everything he says is true. They knew this and discarded his assumptions and used what they knew to be facts to prove other things. Descartes wrote a book called Discourse on Method, in which he describes how he decided to rid himself of all authorities and search only for knowledge that was completely provable. He was left with doubt, and so he said that the doubter must exist. He made his famous statement, "I think, therefore I am," which I take to mean that anyone who doubts or thinks exists or is. Isaac Newton read the works of many important men of his time and eventually came up with his theory of gravity. This explanation linked physics and astronomy and explained why the moons kept traveling with the planets as Galileo saw. Gravity also explained why the planets would orbit the sun, because the sun is so much larger than the planets, and not the other way around. This important discovery stems from Copernicus' theory, showing that his influence in the scientific revolution was huge. Chemistry in the Middle Ages was almost entirely alchemy. During the scientific revolution, chemists turned away from foolish notions of turning lead into gold and made important discoveries, such as Robert Boyle discovering the difference between an element and a compound. These discoveries were made in the revolution that Copernicus initiated with his heliocentric theory. Physicians in the Middle Ages relied mainly on Galen, who lived in Roman times, for anatomical information. However, Galen had made some mistakes concerning anatomy, and physicians of the scientific revolution realized this and fixed it. They improved medicine tremendously, creating a vaccine for smallpox, a huge advance. People challenging ideas of long ago is a theme that was present in Copernicus's life as well. All of these scientific successes and advancements inspired people. They believed in the power of human reason and thought that they could create a heaven on earth through political and social reform. This period of thought is known as the Enlightenment. All of these events were kick-started by Copernicus when he introduced his heliocentric theory. He was the most influential and important person of the scientific revolution in the era that followed.